And the last one that we have to look at is the graph of Sine X. Again, we do the same thing. So the domain, X is an element of all real numbers, and we see that it goes on forever in both directions. The range, Y is an element of all real numbers. Now this time, we see that it only oscillates between two values, from positive 1 to negative 1. So negative 1 is less than or equal to Y, which is less than or equal to 1 for that. The range, zeros and y-intercepts. Well, the zeros are interesting. There's one at 0, and if you remember your graph sine curve, there's another one at 180 degrees and 360 degrees, and there's another one at negative 180 and negative 360, and it goes on like that forever. So basically it is 180n, so x equals 180n, where n is an element of the integers. And then for the y-intercept, y equals 0. For intervals of increase and decrease, now this one's a little bit trickier. We see that, let's take a look at the increase for now here. We see that it's increasing from negative 90 to 90. And then it begins increasing again at positive 270 and continues up to 360. Sorry, no, it continues to 450. Okay, so it looks like here it's increasing for a whole 180 degrees, and it takes 180 degrees to decrease, and then it increases again for another 180. So if we take a look at if we just take a look at the interval of increase for now, so it goes from negative 90 to 90. I'll just write this in here. Goes from negative 90 to 90. And so we just focus on the negative 90. We see that from negative 90 over to 270, that's a whole wavelength. That's a whole 360 degrees. So it's negative 90, and it repeats every 360 degrees because the wavelength keeps repeating. So it would be negative 90 plus 360k, again, where k is an element of the integers because it could be negative. And then for the positive 90, for the end of the wavelength, the end of the interval of increase, it's positive 90, and again that repeats every 360 degrees, where k is an element of the integers. And so then if we were to put these two together, the beginning point and the end point, so it would be negative 90 plus 360k to 90 plus 360k, in both cases where k is an element of all integers. And then just one last little thing we have to do here is we should probably factor a few things out. So what we can do is we can factor out a 90 here and get 4k, and we'll switch it around, 4k minus 1, and here's 90, 4k plus 1. Okay, so we're just factoring out 90 from both of those, and then that would give you 4k, and that would give you the plus 1. So we just turned it around, so it's 4k plus 1, and we factor out a negative 90 from both of these, and when you divide, I'm going to just factor out the 90, so excuse me about that. So 360k divided by 90 gives you 4k, and then negative 90 divided by 90 gives you negative 1. Okay, again, k is an element of integers. Okay, so that is the interval of increase, and in a similar fashion, the interval of decrease can be done where if we take a look at perhaps this spot from 90 degrees, where it starts to decrease down to 270, we can say it's 90 to 270, and we know that this 90 degrees, the beginning of the decrease happens every 360 degrees, the end of the decrease happens every 360 degrees, so it'd be 90 plus 360k, where k is an element of all integers, of course, and 270 plus 360k. And then factor out the 90 again. So basically we end up getting 90 degrees. I guess these should be 90 degrees here also to make sure it's all official. 90 degrees, 4k plus 1, and 90 degrees, 4k plus 3 when you divide, where k is an element of all integers. And then, so that's the tough part. Then the rest of it's a little bit easier. For part 4, discontinuities and asymptotes. Okay, so there are none. Even though it oscillates back and forth between negative or positive 1 and negative 1, it's not actually called a horizontal asymptote. Part 5 is symmetry, even or odd. Well, if you were to flip that horizontally in the y-axis, it would not be even, but then if you were to reflect it in the x-axis, we would see that yes, indeed, it is odd, so that is an odd function. And then one last bit, as x approaches infinity, y kind of oscillates back and forth, so we don't really actually have an end behavior. We say y, well, as x approaches infinity, y approaches all these values, so we can't really say that there's true end behavior. It's just kind of oscillating. So there may be fancy ways of writing that, but I would just leave that as it is without having a specific end behavior, because the y approaches somewhere between negative 1 and 1. And as x approaches negative infinity, y approaches somewhere between negative 1 and 1 also. So it's kind of oscillating, so that's probably not the best way to actually even write that final statement there. Okay, so let's take a look at this then. Okay, so then we basically have a graph that kind of looks like that and just continues oscillating forever. Domain, x is an element of all real numbers. The range, y is an element of all real numbers such that negative 1 is less than or equal to y, less than or equal to 1. Intervals of increase, we'd say 90 degrees, 4k minus 1 to 90 degrees, 4k plus 1, where k is an element of the integers. Intervals of a decrease is 90 degrees, 4k plus 1 to 90 degrees, 4k plus 3, where k is an element of the integers also. Location of discontinuities and asymptotes, there are none. Zeros, well, x is 180 n, where again n is an element of the integers. Y equals 0. Symmetry, that's odd. And end behaviors is kind of oscillating.